Hello and welcome to this new tutorial, and in this tutorial we will learn how to do COVID-19 test classification using Emgu CV. Here is the demo of the application. We will open an image. Let's say this is the COVID-19 image, and when we click on COVID test, it will show that this is the positive, this is positive, this is positive, and this is the negative. So according to the information provided for the positive and a negative test. So we will be focusing on this part only. So let's see how we can do this. I have already created a project in Windows Forms application and configured it to use EmguCV CV 4.5. You can check one of my previous videos. I will go ahead and add a new submenu item into my menu, and under this process into the drop down collections, and I'm going to add one more item. Let's say we call it COVID-19 test. I copy it and also put it here as it is, underscore. Okay, and then click on OK, and this is not the valid name, so I write it like this. Okay, and then in the menu here we will select this COVID-19 test submenu item, and from the events let us double click on it. Here I will write a try catch, so try, and if we have any error we will have to handle it. So the first thing, I assume that the user must have opened an image. So when using the open, and then we show the image in here, and also add the image into a dictionary which I created before. So this is the image of dictionary. So we can check that our dictionary has some item with the name input, otherwise we will give an error. So here I'm just going to make sure that I have at least one image to process it. So if image dict dot contains key input, in fact I should say if it does not contain that key, that is not, then I will throw an exception, throw new exception, which we can say like select an image first. So if we have an image, then we can read that into a variable, call it img dict, and then we can use the index, string index, its name is input. And before using it, I would like to smooth it a little bit, so I'm using this smooth Gaussian, and the kernel size I'm using is 3. The next thing is, we can see here is this is the image that I will be using. The background, as you can see, is white, so I need to convert it into a grayscale image, and then in fact apply some edge detections to find out the boundaries for these elements. So let's do that. I just create a new variable called edges is equal to img.convert, and we are going to convert it into a grayscale image. The depth will be the same, and what I want to do is to apply this scanning edge detector to find the edges of these elements. So let me use a threshold. This is what we may need to come up with an optimal threshold value. Let me test with 150 is the strong edges, and the ones with this weak ones I just considered as 50. And we can look at the results actually. Img is equal to edges dot image is bitmap or to bitmap, and then let's see what actually it gives us. And when we click on COVID-19 test, perfect. So the edges that I wanted to find is over here, and we can also do some dilation if there are some small edges somewhere or small elements. I just want to suppress them, and if there are some discontinuities, I just want to connect them also. So to store the results, I'm just going to create a variable called morphology is equal to new mate object. Sorry, what is that? I just want a mate object. Sorry, mate. Okay. So, and then we can apply CV invoke dot morphology extension. In fact, I want to use a combination of both dilation and erosion, so we can easily use this. Edges will be the input, and a morphology will be in fact morphology is the output that I want to store, and the operation that I want to perform is dot closing. So it is a combination of both erosion and a dilation, and the structuring element that I will be using is basically a simple a 5 by 5 structuring element, and let's say the def type to be just CV unsigned 8, and we have only one channel because the input image is a gray channel. And it is also asking what we are going to do is the anchor point. So the anchor point is the point around which we are going to make a calculation. So -1 and -1. So it is the central pixel. And the next is the number of iterations. For here, let's say we are repeating it 3 times, and let's see the results if they are satisfied or not. And the border type, just I'm going to use to be a constant or default, let's say whatever the value, since we are not using any constant this around the border. So I just set this value to be 0. Okay, so once we do the morphology, let's see the results. Actually, this is also important. If there is any problem, I don't need to do it again. Morphology, we have to use to bitmap. Okay, let us run it, and again when we set it, okay, looks good. Now if I find the contours, and now this time what I want, this will be the external contour. When we select the external contour, it will give us these external contours, but I'm not interested in those external contours. I am interested in the contours which don't have any child. For example, this one has no child. I mean, there is no contour inside the contour. So for example, I will be interested in inside this one. So you can see that this is one contour. I just want such contours. I will want to select them. So I'm going to find out those contours first and apply some conditions in order to find these contours. So let's go ahead and declare two variables, vector of points to store the contours, and we call them contours is equal to new vector of contours, and also the hierarchy information is equal to new hierarchy. So now hierarchy is very important for us. So CV invoke dot find contours, and this one is expecting the input image, that is the morphology. This is the image, and we want to get the outputs in the contours is output. The hierarchy is H, and the retrieval type, now I don't need the external, I need the whole details of all the contours present there. So this one will be now a complete tree, so which contains the parent information, the child, and who is the left, who is the right, all those information. And chain approximation dot simple, just let's keep this one to be as simple one. This contour retrieval type dot tree is basically important here to store the information in this mate. So when you look at this OpenCV, let's see this 5.4.552 on OpenCV, the hierarchy information will be stored like this, as you can see. the contour ID, which will be the next, which will be the previous, is there any child, is there any parent. So this will be basically a mate which consists of 4 channels, or these 4 information. So you can see here, for example, this is the 0th, let's say, contour ID is 0. It has no children, it has no parent, it has no, which is the next and which is the previous, it's nothing here. So if there is no parent or if there is no child, then its value will be -1. So this is what actually I will be using here, and I'm interested in the finding the contours which have no children. So once we get that, I will be working with the what we call it, the contours and their hierarchy. What I will do is I want to create a new variable, call it processed, and we can say that edges dot copy blank. I just create a blank image from the edges images, that is the gray image. So what I will do is to loop through all the data in this mate. I can copy it into a variable called data is equal to h.getData. So this one will return me basically an array of arrays. You can see this is an array element. So I'm just going to copy it. We can have a look at that, what this data is. So I'm going to run it again and then COVID test. Now, if you look at this data, this is basically 1 by 68 by 4. So this 68, so these are those 4 values, as I said, next, previous, the child, and the parent, and then for the next contour. So this indicates that there are 68 contours and the 4 different information of all those contours. Now I need to loop through this 4-dimensional data one by one. I call it row or whatever we call it, or and data.getLength. In the first dimension, that was 1, as you have seen. For another integer c, which we can call it c or integer, whatever call it, data.getLength in the second dimension, which was 68, remember. And then I'm looping through all these, and I'm going to select all the contours which don't have any child. So the child information is present somewhere here. So I'm going to look at the 0th, first, and the second. So I need to check what is the value in my data in the second index. And also I need to make sure that it has some parent. It should have some parent. I mean, if it is inner, then it should have some parent. Its value should not be equal to -1. So these two conditions I'm going to use here. If data.getValue, I'm going to read the value from, and here we need to provide the index. The R and the C will be, and then I'm going to select the index number 2, which indicates the child element. And this one is returning the object, so I am not actually interested in object. I am interested in an integer, so I'm going to convert it into integer like this. Let's do it like this, what it will do. Okay, and outside it one I will also make something like this. If this one equals -1, this is for the if, this is one condition. It means that there is no child element. And another condition, that its parent should be greater than -1. It means that it has at least one parent, and the parent index is 3. Okay, so I am looking at this one and this one for each contour. If it is so, then it means that we have the innermost child element, and I just want to show that. Okay, we can directly show that CV invoke dot, let me draw a contour for that. Which contour I want to draw? It is on the pre-processed. I want to draw it, and we have all the contours. Here I can give the ID, the seed contour that I want to draw. The color that I want to make is 255. And the thickness I want -1, that is I want to fill it. By the way, okay, let's see the result after pre-processing, what happens, and then we will take the next step. In fact, it is the second dimension, not the third one. So that is what exactly I wanted. So what I can do now is we need to keep these. I draw the contours, and in fact, the contours which are longer and taller, we can keep them. For example, this is the one that I can ignore easily inside this for loop. So one thing more, I will make a change here is I will write a condition based on the bounding box. So first I need to get the bounding box, and we can calculate the bounding box for the contour by using CV invoke dot bounding rectangle. And inside it, I'm going to give the contour for which I want to find it. So here it will be the C index. So this is going for the all the contours, looping through the contours. And once I find this bounding box, I can find the aspect ratio. Aspect ratio is AR, we call it. Let's say AR is the ratio between width and the height. So let us calculate that, and we can find the bounding box dot width divided by bounding box dot height. And this one will be the aspect ratio. In fact, one of them should be float. Let's say this one, since this is going to be integer if we do not do this. I don't need this last one. So when we change one of them to be a float, then the result will be a float. Okay. And then we can put a condition here. If the aspect ratio is less than or equal to 2.0, let's say, then we can draw the contour. Otherwise, we don't want that contour. So let us see. I hope that some of them will be refined. So here you can see some of them have gone and only few are left, but we don't need rest of them. Only these contours are required. So one thing that I can do is further process this image. And if I do a dilation with a structuring element that is longer in height, then it will combine these together. So we will have a longer one contour for inside it. And I'm basically interested in inside of this one. So I'm only interested in identifying this part only. So if I get a longer one, then I will be able to remove rest of them based on the height. It has a bigger height and the ratio will be higher, so then we can remove rest of them. So once we have, let me create another variable. Let's say initial output 1. Let's say output 1 is equal to, we can do the same thing, edge dot copy blank. So I just created a blank copy blank version with the same size, but all these will be set to 0. So let us apply the dilation. CV invoke dot dilate, and here we will provide the pre-processed image as input. Okay, and the output will be output 1. Here I want to write it, and the structuring element that I want is mate dot ones. So I need a structuring element with large number of rows and only one column. The depth that we can give is an unsigned, and we need only one channel. Okay, and the next parameter is the anchor point, which will be -1 comma -1, indicating that it is the central pixel that will be around which we are doing this dilation operation. And the border type that we want, type dot, that's a default whatever the border is going to be. And the border, sorry, the third one is the border type. The next one is the number of times that we want to repeat it. I say only one time. And we have this border type, and what should be the value? Let's say 255. Okay, or maybe let's set it to 0, for example. Okay, so this one will result in the dilation. And then for that image, I'm going to calculate the contours again. So now the previous contours, I don't need them. I just want to clear them. And again, I will find the contours for this image after dilation. So cv_invoke.find contours, and we are going to get the contours for output 1, and the contours that we are going to store is in the contours object. The hierarchy is in H, and retrieval type. This time I am only interested in the external contours because we have just one contours that we want for the innermost one. So chain approximation dot simple one, and that's it. So once I have these contours, I can now loop through those contours and eliminate the contours which are not in the middle or the longest ones. The ones which are not these contours have some small width or height, and then we can remove them quite easily. So one thing that we can see that for the middle one, the height is at least 2 to 3 times greater than the width. So I can write a condition: if the height and the aspect ratio is 3 times greater than the width, then we can consider that as our results strip. So I'm going to write a for loop for I is equal to 1, and we have contours dot size, and we need the bounding box for each contour. So I'm going to write it cv invoke dot bounding rectangle, and for these contours, ith contour, we get it. And once we have the bounding contour, I'm just bounding box for each contour, then I can write the condition bbox dot height is greater than, and if height is too much greater than, let's say the bounding box dot width multiply by 3 times. If it is greater than 3 times, let's say, then we consider that is a strip because we don't have any other object that has something like this. Okay, then what we want to do, then we want to count how many contours are there inside it. So once we say that, okay, this is one of the contours, and then I want to see if I find that this is the only contour that we have, then we have to count how many contours are here. For example, here if you see, this will be one contour, this will be another, this one will be another. So this is a negative one. So here you can also see there will be 2 blocks only. So this is negative. There will be 1, 2, 3, 4 parts, and only in this case is considered to be positive. So again, what I will do, actually we had 2 images. Okay, so once this condition is satisfied, then we can draw the contours. So what exactly we need to do, we can create another variable, and we can say that final output is equal to edges dot copy blink. Okay, and on this one we can draw it, cv invoke dot draw contours. We have the contours in our hand, and we have, sorry, this is not the one, the image that we want to draw it, final output, and we want to draw these contours. But this time we need to provide the ID. So the ID which satisfies this condition will be the ID of the contour, and what should be the color. So it is a grayscale, so I give it -1. And also thickness we can provide. If we give -1, then the contour will be filled. So this is what exactly I want it. By the way, just once we do this, we can check the final output before going further to see that if everything is going in the right direction or not. And you can see this is the perfect. So this is what exactly I wanted, and I get the strips. Now, once I know the strips, then I can count the divisions inside it. Then we can say that if there are 2 divisions, then we have this positive case, and more than that else case we will have, sorry, if we have only two divisions, then that is a negative case. In rest of all these cases, we can say it is a positive case. So the interesting thing, we need to count the contours for these each one. So what I am going to do is we need to find the contours for each block. So what it can easily be done, since we have many four contours, so we can write a method and use it again and again, private, and this one will return the number of contours in it. So we can say count contours, and we need to pass in an image, actually a gray image, gray and white. Anyway, say that img, and inside it let me create a try catch, and if there is any problem we can throw a new exception here, and whatever the error we have, we can pass that exception as it is, ex.message. Okay, and here what I will do is, again I will calculate the contours vector of point for that image. We can call it contours is equal to new contours, and a mate to store the hierarchy, or in fact we don't need the hierarchy. What we can do here, CV invoke dot find contours, and here we can pass the image, that will be img, and outputs will be in contours, and contours, and we are going to pass the null. I don't know whether this will work or not, so let's try. And I need only the external contours and a chain approximation dot simple one. And now once we have the contours, we just need to count them and return that. So contours dot size. This is what exactly I just want to return. So we give an image, we find the contours for that image, and then we return it. But what will be this image exactly? Will be the image of the contour itself only. I mean the white area. So this is very important. Before calling it, what I am going to do here, the pre-processed image dot ROI. This is very important. And this will be the bounding box. This means that I am only processing only that cropped area. And then we can use this integer count is equal to contours count contours method, and inside this I'm going to pass this pre-processed image. It's not the whole image, so it will be only processing this ROI region. And don't forget to reset to original contour right after using it. So I'm just going to set it to be rectangle dot empty. So it means that we just removed that contour. We processed it and then we did it. Now the interesting thing, we need to make a decision that if my contour has only two parts, then we can say it is negative. If it has 1, 2, 3, 4, 1, 2, 3, or three parts or four parts, then we can just declare it as a positive case. So that is where we will using this count. So we can write it a string message is equal to, let's say it is empty, and also we can select a color, CV scalar, and call it color. And if this count is equals to, then we can say message is equal to, this will be a negative case, negative, and the color will be is equal to new scalar, and what we want to do a color is a green color, BGR. Okay, else if it is not, then what we can do, we just copy this portion and we can say positive, and we can set the colors to be red. That's it. And we can then display this text also, cv invoke dot put text, put text, and we can write where we want on the original image, and what is the message that we want to show, and on which location we want to show. We can use this bounding box dot x and the bounding box dot y, and also we can use font face dot plain. Okay, and then if we want to scale it 2.5, let's say a little bit bigger, and the color that we have selected, that will be the color, and the thickness, let's say I want to set it to be 3. Okay, maybe instead of putting on this, we can put a margin, let's say we can set a margin of 50, and we can subtract this one a little bit back, so x minus margin, and we can add it so that it will maybe also subtract it. It should go a little bit upwards and backwards. Okay, and that's it. So we just put an image, and we set the result, and then we can display it also, img.toBitmap, and let us run it, and let's see if we can select it. And for this one, when I say COVID-19, okay, so this is what exactly we were looking for. And where was that COVID one? Is this in line with this one or not? So we have these, sorry, this is the positive, 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 and the one is negative. This is exactly what we did for the COVID-19 test. So one thing, remember that if we change the size, so there are many things that I have used here with the fixed, for example, multiplication with this one. So with the changing the size of the image, we may need to do it dynamically. For example, for the pre-processing of this dilation, and for the closing, we have selected these things. But if the image is changed, then we may need to dynamically change these values. So that's it for now, and hope to see you in another video.